standing ground, folks. This is just a quick video. I just went over this with one of my other guys. This is just something that we took from an installation manual from a forced hot water boiler. And one question that one of my guys brought up was, what is the difference between a ladder diagram and a pictorial diagram? Now guys, if you're not familiar with this, you'll see this usually on the door of the furnace or boiler. And let me zoom in here to show you. And as you can see, usually it'll be sideways on the furnace. Usually towards the left, you'll see the ladder portion, and on the right side, you'll see the pictorial. But guys, a ladder diagram just shows the system components, nothing more. Consider this a blown out portion of the system. The pictorial diagram is where you'll typically see the wires and you'll see the more in-depth components of the system. Now guys, once again, this is what I took from a hot water forced boiler. And I'm just gonna run through this here to show you guys a few basic components. And this comes in handy when you guys troubleshoot. Every system residential, you're gonna have an L1 and L2. This is 115, 120 volts. And as you see, our transformer, which is what steps our 120 down to our 24. This is very important for guys that don't know. With this transformer, this is what splits your system up from 115 to 24. So just off looking at this diagram, I can tell that everything below the 24 volt side is going to be considered 24 volts. And everything on the primary side is going to be 115. Excuse the handwriting here. But guys, as far as on my 115 volt side, the only thing in that boiler that needs 115 is our circulator pump. Now guys, on this particular boiler, this wasn't a multi-zone boiler. We just had our circulator, but on our 115 volt side, the only thing that needs 115 is our circulator. But as you guys can see, your service switch, which should be your emergency on and off switch, this is how you turn your system off and on. If we trace it from here, you wire nut it, goes into here, and this is our boiler controller. Consider this like an aquastat internally. With forced boilers, they have the little black internal aquastat with the probe, which senses the temperature of your boiler, but also on the front of the aquastat, you have your wires where you have your incoming voltage side, and you also have your wires that hooks up to your circulator. And of course, there's some data here as far as with the full load amps. But guys, unfortunately, this isn't from an actual door. This is just an extra sheet. But on some schematics, not necessarily with the ladder, but the pictorial, most of the terminologies are abbreviated. So for instance, I'm gonna jump back and forth here, so bear with me. On some furnaces, you could have FRS instead of flame roll-out switch. They just abbreviate it. Sometimes with the abbreviated meaning, guys, if you guys don't know what the abbreviation on the pictorial side is, you can always refer to your legend. A legend pretty much explains the abbreviation or the indentations as far as with the wiring. And it pretty much tells exactly what the terminology is. So instead of, second guessing what the part is, you can always go to your pictorial, find out what the abbreviation is. In this case, guys, there is no need for the legend to give us the abbreviation because they didn't abbreviate it here. As you can see, you got your block vent switch and you got your flame roll-off switch. But guys, going back to our ladder diagram, and as you can see, ladder, as you can reference with the rungs of a ladder, if the system had more 115 volt components, it will be in a vertical orientation. But guys, on the ladder side of this boiler, there's really not much to really go off of besides the service switch, the aquastat, and the circulator, which is all once again 115. And guys, once again, this is the primary side of your transformer. Primary side of the transformer on this hot water boiler is going to be 115, and then the transformer, if it's operational and you have your incoming side hooked up right, is going to step that 115 down to 24. And this is where you get into the bells and whistles and more of the intricate parts of this boiler. As you can see, if we trace this down, and we're going to say for educational purposes, this is R and C. Vice versa, it doesn't matter, but let's say this is R. If we trace this down here, our IDL is technically our aquastat. And like I said, guys, this isn't the door from the unit. If you had to look at the actual door of the boiler, it would probably tell you what the IDL was in the legend, but I feel like this is just an optional sheet that comes with the install manual. But moving along here, power goes through the 24-volt side of your IDL, and as you see, it has an auxiliary limit. For those that don't know, the limit switch is what senses the internal temperature of your boiler, and it turns it off if the internal temperature exceeds a certain amount. So what will happen is the limit switch is going to say, hey, my boiler's too hot, let me turn the burners off, but let me keep the circulator pump running to remove that heat from the boiler to cool it down. In the meantime, the house will still get warm, but the boiler itself has to cool down until it gets below the limit switch setting. And once the limit switch setting goes down, it engages, and now the burners turn back on. But as you see here, we're gonna move along here. Once the limit switch makes, now you have your flame rollout switch. And guys, one thing that's very, very important for you to know, all safety switches are gonna be wired in series. Let me explain this here. You have series, and you have parallel. And this is back, I might be spelling this wrong here. But you have series and you have parallel. This is back to electricity 101. Guys, the reason for your series to be wired, well, the reason for your safety controllers to be wired in series is that when one controller opens up, everything turns off, right? A series circuit, think of this like one big circle, right? You have your limit switch, flame rollout switch, could be a block vent switch, a BVS. It could be a backup limit switch or XYZ or blower limit switch, whatever, right? If one of these switches open up, you essentially open up the circuit. And if you open up the circuit, your burners turn off. That's the point of any one of these safety switches. If flames shoot out of your furnace due to whatever, that's considered unsafe. And if this flame rollout switch opens up, it's going to basically break the circuit. Once you have an open circuit, no electricity flows through it, and that's how the flame rollout switch is going to kill power to your system. But guys, another thing to mention, everything is going to be normally closed until something happens and it opens up. Here's an example. Normally closed, meaning without power flowing through it, it's going to be normally closed, and it opens up on either a rising temperature or whatever causes it to open up. Typically, most of your safeties on a furnace, meaning your rollout switch and your block vent switch, are going to be normally closed, and it's a bimetal that warps whenever it gets hot. Meaning, if your flame rollout switch senses too much heat from the flames backing out of your boiler, or if the block vent switch senses the flue temperature exceeding a certain point, it's going to warp and open up. Meaning, normally closed is going to open up like that. Guys, normally open, you're not going to see too many normally open controllers in residential heating. Typically, normally open controllers, you'll see this a lot more in like refrigeration. But with residential purposes, most of your safety is going to be normally closed until, like I said, something happens that causes it to open up. But guys, blowing through this here, once again, this is our 24-volt side. Our flame rollout switch closed, block vent switch closed. And now guys, let's get to the end switch of your damper. Now I made a video on the damper not too long ago. You do have an automatic and a manual lever on your damper. Typically you want to keep this damper automatic. And once again, this is like the efficiency thing that I went over. But this damper, inside of it, you have a switch. If that damper doesn't make, this will cause the unit not to work. But like I said, going through your damper, assuming that damper is closed. Next, you have your gas valve. Now guys, I want to say 100%, unless you have like an older system, 100%, most gas valves now are going to be spark ignition. You're not going to see hot surface ignition boilers unless you're dealing with certain 90% units. But just to keep things simple, this is an 80% hot water boiler. 100% of the time, you're gonna be dealing with spark ignition, brand new boilers. Back in the day, remember you had, and you probably still see these around, your standing pilot units with thermocouple and all that. Unfortunately, those things aren't as efficient down the line because on a real windy day, pilot light goes out and now the customer's calling you to come back out to light the pilot. But they eliminated that headache and just went with spark ignition. Spark ignition is the intermittent ignition. This will allow the pilot to only be lit on a call for heat. So on a windy day, this doesn't have any effect on the spark ignition, meaning this is only gonna light on a call for heat and turns off once the house temperature is satisfied. But as you see, you got your 3 terminals, NV, PV, and NV-PV. One goes to the main valve, one goes to the pilot valve, and that's your common. But as you can see, I just want you guys to get a look at this Pictorial side of the diagram. Not only does it show your components, this shows how everything is hooked up. Don't get me wrong, guys, both of these schematics are important, but from my experience, I had a lot more luck with the Pictorial side. The only thing I really need to know is, for instance, let's say if I'm dealing with a furnace and maybe the previous contractor, maybe he took apart something and now I open up the door to the boiler and everything is not hooked up right. Every single time, from a point of reference, if I can find out what the part name is on here, I can pretty much know how to hook it up and what wires it hooks up at. Now, unfortunately, guys, this didn't come from the door, but the difference between this sheet I'm showing you and the door, well, in the schematic you'll see on the boiler door, you will actually see the color wire that it connects to. So you'll see, for instance, it'll be red, red, yellow, yellow, and you'll be able to actually match what you see here on the actual unit itself. But I'm just showing you showing this like from a point of reference to show you guys that Pictorial definitely has more details than the Ladder, but both are still important because unfortunately, guys, with the Pictorial diagram, this doesn't show you anything on your boiler that's 115, right? This doesn't have a circulator pump on it. As you can see, there's no circulator. You'll have to go on the other side of the transformer, which is your primary, to spot your circulator. So that's important to know too, especially for guys that's starting to, use schematics a lot more. I know some guys, luckily if you've been around long enough, you might have already seen this, but like I said, guys, I like making these videos because like I said, sometimes you're not going to even need this on some service calls, but when you do get that electrical scenario and like say you feel like something was done that maybe the customer's not telling you about, and now you look on this and say, hey, what about my block vent switch? This schematic says this thing has 2 red wires coming from it. Now I look on the unit and it has 2 black wires. Wait a minute, what was done? And like I said, this is why schematics are very, very important. I always train my guys to know what the parts are, And like I said, I can only speak from my own experience and my own service tech's experience. Like I said, looking at parts and memorizing parts are cool, but if you can match that back to the point of reference on a schematic, this is where, like I said, service comes in handy for you. And and the more experience you guys get with this, and the better you get at it, like I said, you'll have this already burnt in your head to, hey, when I look at a furnace, okay, when I'm troubleshooting, I know all my safeties are wired in series. So even if I have a block vent switch error, my flame rollout can still be closed, but it still won't light because, I have another safety in the circuit that's opened up. It's not closed. So I hope this helps out, guys. Like I said, I'll make a lot more, like I said, random videos like this down the line, but I'm just showing you this because we literally just spoke about this. Me and my other guy here, I'm training him on just troubleshooting electrical boiler or troubleshooting the electric side of boilers. Not every one of your no heat calls on a boiler is going to be is going to be a pipe leaking or anything like that, guys. You heard this a million and one times, and I'll say it again. 80% of all issues are going to be electrical related. So if you're at a boiler and you got that meter, don't get me wrong, you need the right tools, but you also need the right education on how these things work. And most importantly, if you have that boiler with a schematic on the door, which is similar to what I'm showing you here, not only will you know how to find parts, but if you look at the Pictorial side, you'll know exactly how to locate parts and know how to troubleshoot them. So there you guys have it. Pictorial, Ladder, Pictorial, and how to navigate through each one. Peace out. I'll see you guys on the next one.